Good afternoon. Thank you for joining us for today's webinar. The webinar today is presented by New York BEST, the New York Battery and Energy Storage Technology Consortium. The title of our webinar today is Electric and Hybrid Buses, Technology, Performance, and Markets. Just quickly, we want to review logistics for today's call, or for today's webinar. If throughout the course of the webinar, if you have any questions, please type them into the chat box that you see on the side of your screen. Any questions that you have throughout the course of the webinar, just please type them in, and we will be addressing questions at the end of the webinar. But feel free to enter them during the course of the webinar. Also, at the end of the webinar, you will be presented with a survey. It's a very short survey. It will take just a couple of minutes to complete. It's very important feedback for us, so we appreciate you taking the time to complete that survey. And lastly, we will be recording today's webinar. So anyone who's interested in receiving a copy of that recording, just please email us at info@newyorkbest.org following the webinar, and we'll be happy to share that with you. And now I'm going to hand it over to John Cerveny, who is New York BEST Director of Resource Development. He will be moderating today's webinar, and he'll be kicking us off with a presentation of today's speakers. John?
Great. Thank you, Denise. And for those who don't know, that was Denise Sheehan who did the introduction.
Jump right in.
Thanks to everyone for joining us today. We're excited to share the topic of today's webinar about electric and hybrid buses. Clearly, on the heels of the climate agreement in Paris, the countries in the world are looking carefully into all options that decarbonize our future transportation sector, along with all sources of energy. And I think this webinar is particularly timely as cities and countries look to finding solutions that work, that have been proven. And I think the span of presentations today are going to tee that up well, and we look forward to sharing these with you. So with us today, we have an outstanding panel of presenters. Sam Jaffe is going to lead things off. Sam is the founder and managing director of Boulder, Colorado-based Cairn Energy Research Advisors, or Cairn ERA. They're an energy research and consulting firm with a focus on energy storage and disruptive technologies. He has more than 10 years of experience in the field of energy research as an analyst, consultant, and entrepreneur. So, Sam, I'm going to ask that you lead us off, and look forward to your presentation. Thank you.
All right. Thank you very much, John. So to start out with just a quick introduction about Cairn ERA, we are, as John mentioned, we're a new research and consulting firm based in Boulder, Colorado, with an expertise and a content focus around energy storage and energy storage markets. So we cover batteries and also the applications for which batteries are used. And in the area of electric transportation, I would say 99% of the hype and the press has fallen on automotive electric vehicles. But the e-bus section has been kind of a silent lion in this space, in the sense that it really has blossomed in the last couple of years, especially in China, but the foundation for growth throughout the world has grown pretty dramatically in the last couple of years. And it's become a major segment for the battery manufacturers that are selling batteries into the transportation sector. And in the case of China, almost at the expense of automotive. So despite almost everything we read and hear about automotive electric vehicles, the electric bus segment really is becoming a major factor in transportation today, for a number of reasons. Obviously, interest in carbon reduction, interest in fuel cost reduction, but the fact is that the larger the vehicle is, the more batteries it can carry, and the benefits of an electric drivetrain become, if done correctly, become significantly more advantageous. So what I'm going to be talking today about is our forecast in the space. We're in the process of finalizing a report that will be coming out in late January, and these are the initial forecast numbers from that report for the electric bus market. So starting out, just to clarify terminology, we look at the e-bus market as a market made up of three major segments. First of all is the diesel-electric hybrid. That's a small battery pack that essentially does regenerative braking power, helps with acceleration. And the numbers that I'm going to present to you in this report and in the next few slides do not include diesel-electric hybrid. I'm just talking about the two classifications on the right. The long-range full-route e-bus, which would be a large battery pack that essentially charges overnight at the depot and then does its entire route for the entire day and then does another full charge. And the third category is the fast charge short route e-bus, which would have a much smaller battery pack, a much higher C-rate capability of those batteries, but the ability to charge during the route. In addition to regen braking, which all three of these are going to be doing, the fast charge short route e-bus would have probably lithium titanate batteries, in some cases ultracapacitors, and it would have the ability to charge either every time it reaches the point A or the depot, but do it during the course of the day, or even during the stopping at the stops. So everything in the numbers that I'm going to be showing you are on these full electric vehicle drivetrain e-buses. What's driving the growth in e-buses? In a word, it's price. So the cost of the batteries are coming down, but it goes way beyond just the batteries. Also, as you can see, the blue lines in these two images for the two segments of buses include the cost of the batteries is the blue line, the orange area is the overall cost of the bus. So both of those are coming down very dramatically, and that in a word is driving this the growth in this market. Now, it's also a very subsidy-intensive market. The growth in China has been primarily driven by subsidies, and that will be true in North America and Europe also. But it's important to note that we're reaching not parity, but an acceptable premium of the cost of an e-bus over the cost of a traditional bus when you look at it from a total cost of ownership or per mile cost of operating the bus. So quickly going into the regions of the world, I've got a slide here for Asia, Western Europe, and North America. Asia is where the dramatic changes happened, and it's all in China. More than 80% of the sales have happened in China, and it's a subsidy-driven market. So we've seen now over 20,000 electric buses are in operation in China today, and that's primarily happened, most of those have been sold in the last 4 or 5 years. There's a number of manufacturers, over 20 manufacturers that we've identified that are making the buses. And I should also point out all of the major battery manufacturers in China are heavily involved in this segment, and they consider it an important part of this growth area. Now, going forward, we expect this to the Asian market to eventually be a multi-billion-dollar market, and we'll see significant growth even going out. There will continue to be significant growth, but beyond 2020, that will really ramp up, and that'll spread beyond China. It makes sense pretty much everywhere in Asia because bus transportation is an important part of transportation mode in most urban areas in Asia, and because of the total cost of ownership advantages of operating an e-bus. In Western Europe, much smaller numbers today, but the opportunity is just as great over the 10-year period. And again, similarly, over a $2 billion market we expect by 2025. And I think the biggest differentiating point is there's a lot more experimentation with newer technologies. There's a lot more interest in the short-range, fast charge, high C-rate buses in Europe. So we expect that there's going to be an emphasis on that type of drivetrain in Europe. And similarly, in the North American market, we're expecting that the fast charge systems will be favored. And also expecting significant growth, although we expect both Asia and Europe to have larger markets than North America over the course of the next 10 years. And you put all these numbers together, and we are expecting this market to grow from what is today about $2 billion worth of e-buses being sold into over $7 billion by 2025. And on the battery alone side, it's already a 2 gigawatt hour market today, and almost all of that is happening in China. But again, that will be more than doubling over the course of the next 10 years, and the types of batteries being used will be changing from the long duration, short or low C rate type batteries to the higher C rate, higher cost batteries. So our report is coming out in late January. If there's anybody that's interested in finding out more information about the report, please send an email to us. And otherwise, actually I have a slide here that says questions. Don't ask questions yet, but please, we're going to be doing a Q&A at the end of the call, and I'll stop my talk there.
Great. Thank you for the presentation. We appreciate that, Sam. Next up, we have John Hroncich, who is a business development manager for BAE Systems HybriDrive Solutions business. We're focusing on regional sales and market development opportunities. John helped commercialize 2 significant New York-based clean technology innovations for the transportation sector, heavy-duty hybrid electric propulsion for trucks and buses, and clean diesel engine after-treatment systems. His work at BAE Systems in Endicott, New York, and at Corning Incorporated in Corning, New York, helped create local jobs and multi-million-dollar business enterprises. John has 15 years of experience in commercial product development in the private sector, has an MBA from the University of Rhode Island and a BA from the University of Rochester. John, please take it away.
Well, thank you very much for that nice introduction. Good afternoon, everyone. This is John Hroncich at BAE Systems. So we manufacture and support a full drivetrain, which is an electric drive powertrain. It's more than just a hybrid. It's an electric drive because it's an electric motor pushing the bus. So there's 2 really different types of hybrids. There are parallel hybrids that integrate into a manual or mechanical transmission, and then our system is what's referred to as a series electric drive system, where the small engine, its only purpose is to act as an onboard generator. So we have 5,000 of these systems across multiple OEMs and across both sides of the Atlantic. So we have a significant amount of product out in the field already. I wanted to highlight three areas that we see really driving some of the numbers in the forecast that Sam projected in the previous presentation. So, you'll probably read a lot about or see a lot in the news about greenhouse gas targets, the large conference in Paris last week. But there's also, it's not just Southeast Asia. A lot of cities in the U.S. are facing issues with asthma and various side effects of air pollution, and are actually coming out on their own, particularly in California, with their own targets to reduce emissions. And so the mayors have come out, and a lot of them are setting fairly aggressive targets. And transit is a part of their solutions as they lay out their plans. When you take that and you fold it into what urban planners are doing, a great example of this is in London, where they set up 2 rings of zones outside of downtown London. One is what's referred to as a low emission zone, and then the center of London is called a congestion zone. So these are areas that apply either fines or penalties, or you have to have a certain technology to not pay a penalty to transit in and out of these areas of London. So there are cameras set up so they can come and fine you if you violate the boundaries they've set up. But this sort of model we're seeing more and more interest in, where you're not only trying to promote cleaner technologies but reduce congestion as well. I took a couple slides out of a Volvo Group sustainability plan because it's a view that we share at BAE Systems that there's not one architecture or type of bus that will meet all the needs of a transit agency. So if you look at the chart here, it talks about 4 different types of buses servicing a city area. We're starting to see this in cities like Montreal, Paris, and in other cities in the UK and mainland Europe, where full electric buses or e-buses operate and specified routes in the downtown area. Then as you move away from the city center, you have what I would consider more flexible or buses that can run either off charging or have longer range. So electric hybrids have a larger battery pack than today's hybrid buses, and they run about 60 to 80% with the engine off. And then the diesel electric hybrids you're seeing, the 5,000 we have out, would fall more into the area of the intercity hybrid, where the engine and the fuel economy is around 20 to 30%. And then finally, in the outer stretches of the city, we see, and we haven't seen a technology yet to replace conventional buses or conventional diesel coaches. So at BAE Systems, this is how we kind of frame up the series system. If you look at the y-axis as what contributes to emissions, you have an engine, a transmission, and accessory loads. Traditional architectures, diesel coach, natural gas buses, and even parallel systems, parallel hybrids, will always have some element of mechanical subsystems. What the series architecture allows is the first step is to eliminate a mechanical transmission with an electric motor. And we can downsize the engine, reducing the engine's footprint, and then start eating into the accessory loads. What we're fielding today are fully electrified accessory buses where the only mechanical subsystem is just the smaller diesel engine acting as a generator. And then finally, that same architecture can deliver all electric buses and even zero-emission fuel cell buses. So it's really the architecture, and it's allowing transit agencies to take steps towards zero-emission transit. One of the buses we're fielding today, this is our Series E-bus, where all the accessory loads are off the engine and are fully placed on the backbone of the hybrid system. This is a commercially available product today. We have about 300 or so in service, where the engine can be shut off and all the accessory loads are being supplied power from the hybrid system. The nice feature about this is that you have your electric drive. You have some limited ability to move the bus, whether it's through a depot or through a no emission zone area on the hybrid system with the engine off, and it does not require any charging infrastructure or plug-in. We didn't claim to turn super hybrid. This is how the guys at Minneapolis talk about these buses, because they're the next generation from their first set of hybrids. So when you, as a transit agency, we are rubbing elbows with the decision makers, and they have a lot on their mind, and they want to go all electric. There's lots of factors that go into that decision, and we like to think that electric hybrids, and sort of the first slide on Sam's chart or presentation really showed the progression where we go from electric hybrids to overnight charge to on-route charging. So the HybriDrive Solutions powertrain allows you to play in all those areas. Okay, I'm going to turn it over to Macy. Thank you for your time. Thanks.
Great, thank you, John. Next up, we have Macy Ashati, who's Vice President of Coach and Bus Sales with BYD, where he's charged with building a sales team for BYD's North American-built electric buses and coaches. Prior to joining BYD, Neshati spent the previous 17 years as Vice President for Sales and Marketing for Complete Coachworks, helping CCW become a dominant bus remanufacturer in North America. Neshati joined Complete Coachworks as VP of Sales and Marketing and led the company to a sales growth of over 700% during his tenure. He's a graduate of Berkeley High School and holds a Bachelor of Arts in Business Management from St. Mary's College in Orinda, California. Please go ahead, Macy. Macy, if you're talking, you're muted. You need to unmute your phone. *7 would do that.
How's that?
There we go.
Is that better? Okay.
Excellent.
Sorry about that.
Thank you.
Thanks for. To me, it's going to sound redundant, but I guess you didn't hear all that. So thanks for having me and giving us the opportunity to give our view of the electric bus market and the evolution. I'm going to leave this slide stationary for a second, just talking for a couple of seconds about the kind of perception of this is new technology and the fear, and uncertainty, and doubt, and the old IBM tactics of FUD that exist in some of our users' minds. And what we try to explain to people is, if you look at New York City, they've been running subways since, or actually electric rail cars since 1869, and underground since 1935. I'm sorry, 1904. Chicago's L has been running since 1892. San Francisco's trolley streetcars, the best I can determine, in the 1920s. And Dayton, Ohio is another example, has been running electrified streetcars or trolley buses since 1933. So the idea of having electric motors driving wheels and having the electronics that make all that happen on a bus is by far not a new concept. What's really evolved is the battery systems and the density of energy that we've been able to get into batteries from various manufacturers, that has made it possible now to put that energy source from an overhead catenary system onto the bus and basically unleash the battery, the bus from the overhead lines that kind of structure where it can go and where it can't go, and how far out to the residential areas it can reach. So we've basically unleashed this beautiful zero-emission vehicle that's been around since the early 1900s, and updated it for the 2000s by bringing the energy source on board. That's really the big differentiator. So if we can get people to start accepting the fact that this is not new, scary technology, but very proven, very reliable, very stable technology that's just been enhanced with onboard energy system instead of a reliance on overhead system, I think we can make this market move along a little bit faster, benefiting primarily all the citizens of this world by giving them cleaner air. So BYD's unique approach to this industry is we are primarily, our core technology, our core competency is a battery manufacturer. We started 20 years ago as a battery manufacturer, supplying batteries to companies like Motorola, Samsung, Apple, DeWalt, Power Tools, just a whole host of who's who of industry in terms of battery usage. Over the years, we acquired a car manufacturer, and from that we evolved into a bus manufacturer, and our headquarters in Shenzhen, China, and since that point have opened up operations in Los Angeles. Our headquarters opened up in 2011 in downtown LA, and our manufacturing plant opened up in 2013 in Lancaster, California. We also have our energy division up there, which builds our battery packs and modules. So that's kind of a little bit of where we are right now with that. So our core, we're vertically integrated. We build our own batteries from the cell. We build the cell all the way up to the module to the battery pack. We build our own high voltage electronics, our own inverters, and our own traction motors, which are direct mounted to the axles for higher efficiency and smoother operation. So what's going on with batteries that's really exciting from our standpoint is the ability to continue to improve energy density and formulation so that we're getting long lasting cycles. Our iron phosphate formula, we've proven in a very harsh environment of minus 40 degrees up to plus 140 degrees. Repeated cycle testing and test cells have gotten us out to 10,000 cycles and still maintaining about 70% efficiency. So if you take 10,000 cycles and divide that by 365 days, you get a long lasting battery. So that makes the battery much more feasible on board a vehicle. We're saying the 70% is at about 27 years. At that point, the battery's still good, still has 70% capacity on it, but it may not be good enough for transportation, but we would then take those batteries off that and start putting them into energy storage applications where they would last another 15 to 20 years. So as the battery technology increases, the energy density increases, we're able to do more and more, go further and further on a single charge. And that makes these buses, again, more and more usable for virtually any transit duty cycle, at least in North America, and what we've seen is probably most of the world. So since 2011, our energy density has increased 7.4%, and we're forecasting another 11.4% through 2020. And that's just basically through research and development. And obviously, and I don't want to dwell on this because there's a lot that's already been said and done about greenhouse gas emissions and freeing ourselves from fossil fuels, but there's significant, obviously, impact by doing so, and there's a chart that shows that. What we're trying to do, again, in terms of getting rid of the end user uncertainty, fear, and doubt, is we've, knowing that we have a 27-year battery down to 70%, actually, if we cut that down to a 12-year battery, which is what the Federal Transit Administration sets as the minimum life expectancy of a transit bus in the United States, at 12 years, we're still well above 80%. We're still above 80% generally in our testing at 20 years. So we've included a standard 12-year, 500,000-mile battery warranty. It's a no-nonsense warranty. There's no fine print, no mincing of words. If the bus doesn't make it to year 12 or 500,000, and through the useful life as defined by the FTA, we'll replace any bad pack or any bad module that needs to be replaced to finish out its life cycle. We'll also include our chargers with our buses, so there's no extra infrastructure costs. And the bus has V2V built into it, V2G built into it, V2V built into it, so that we can act as a generator feeding power back to buildings, other cars, or other vehicles that need battery charge. In times of emergency, we can actually reverse feed off the bus back to a building or other structure. So the bigger picture from our point of view in terms of this market development and the evolution of batteries and battery storage is our chairman really sees things in terms of his three green dreams. It's been a theme of his that inspired me and made me want to come out of retirement and come back to work for BYD. And that's that we envision a day where we get rid of wars over petroleum and who's got the oil and where and how they're going to sell it and where it's going to be distributed and who's going to control the price. We see a world where we look to the sun and capture its power, and it's one of those things that no one can come over and have a war and beat you up about how much sun you're getting or how much sun they want from your country or how much sun we want from their country. It's abundant, it's there, it's for everyone to use, and there's no way to have a war over it. So it frees us from petroleum dependency and makes us and gets us into using sustainable energy. That energy can be stored in our recyclable battery energy storage systems, which again are going to be 35 to 45-year-old life cycles on those storage systems, and that gives you 24 access to the power that you've captured from the sun. And using those systems to charge our vehicles puts us into a sustainable off-grid solution. And right now, our bus line, as it stands currently, includes 7 models, from a 23-foot high-floor bus to a 45-foot high-floor commuter-style over-the-road long-haul coaches, and 4 models of our transit duty vehicles, which takes you from a 30-foot low floor through a 60-foot articulated. We do believe from our research that we have the broadest lineup of all-electric battery buses in the world right now. Several of them have already been through the federal testing requirements at Altoona. Several of the new models have been scheduled into Altoona. Right now we're kind of at the mercy of the Altoona test tracks availability of scheduled slots to get our buses in there and tested. But at the end of the day, we anticipate having all 6 of the 7 buses tested before the end of year 2016. And then we also are have expanded in China and are expanding in the United States our truck production. So we're going to have class 5, 6, 7, and 8 trucks, including airport ground support equipment, cargo and container handling trucks down at the bottom, drayage trucks, Class 8 drayage trucks, delivery trucks, refuse trucks, construction vehicles, and sweepers. And those are all, as you can see, will be released in the United States and North America between the end of this year and the end of quarter 4 of 2016. So that will really broaden our line. All those will be manufactured as well in our Lancaster, California plant. And over the next 2 to 3 years, we intend to start up a U.S.-based dealer network and introduce our sedans and crossover SUVs. The Qin, the Tang, and the Denza, as they're currently called in China, will obviously get more North American-friendly names. The Denza is really an exceptional vehicle. It's a joint venture between BYD and Mercedes-Benz, and is our top-of-the-line luxury vehicle. The Qin will be our luxury sedan, and the Tang will be our crossover utility vehicle. So by the end of 2016, we'll have the full line of electric vehicles that help our country move away from any need for petroleum and fossil fuels, and hopefully with our solar and battery solutions will turn to a sustainable off-grid solution. So currently we're the largest e-bus manufacturer in the world. We have 3,000 buses delivered and or being commissioned for operation around the world. We have 6,000 buses on order globally going into 2016. We have over 100 million miles of proven service miles on e-buses, purely battery electric buses. Rough calculations, 25 million gallons of diesel have been avoided, 25,000 metric tons of CO2 reduced. And just a couple of our North American customers are displayed there for reference. And with that, I will hopefully stay with my 10 minutes and thank everybody for their attention and courtesy during this call. Thank you.
Great. Thank you, Macy. I appreciate your presentation. Next up, Seamus McGrath is Manager of Charge Systems at Proterra, Inc. in Greenville, South Carolina. Seamus has been instrumental in pioneering on-route fast charging, and his team is responsible for systems on and off the Proterra buses that allow for docking and charging at over 400 kilowatts. Previous to this role, Seamus spent the majority of his career working on hybrid vehicle powertrain control systems, including work with quantum technologies on the Fisker Karma, and 7 years at General Motors working on several programs, including the two-mode hybrid program and the early Volt program. Seamus joined GM directly from college, where he earned a Bachelor of Science degree majoring in electrical engineering at the University of Missouri-Rolla. Seamus, please take it away. Thank you.
Yeah, thank you. Thank you for the nice introduction. So Sam, John, and Macy have done a great job here highlighting the market and showcasing some very solid products. Proterra we're the smallest of the group here talking. I really appreciate the time. This has allowed us to have some extreme focus in our products, and so there are some advantages and disadvantages there. As we get moving forward, we'll showcase. Of course, I'm highlighting the advantages. Proterra, we were founded in 2004 by Dale Hill. We currently have offices in California, South Carolina, California manufacturing down in the City of Industry, and Greenville, South Carolina for manufacturing as well. We have 200 employees, strong backing, and strong executive team. We're kind of in the startup category. I would consider us more of an adolescent company at this stage. Our volumes, this is the weaker point that I was alluding to. We're dedicated to all electric and a startup, so our volumes are lower than what we've been talking about in terms of the market and what BAE's experience and BYD's experiences are, but significant because they're fully dedicated. Moving forward, Proterra is our main objective is simply to be the world's cleanest, most efficient transit vehicles. And so, like many of the other people talking today, we really see the zero emissions, the electric, and the pathway to electric as being the strong path there. Our approach, therefore, has been the battery electric. We've had the advantage of no legacy kind of infrastructure. So we've been able to do a clean sheet design from the get-go to build a platform that enables us to support electric transit in the best way possible. So on the downside, we don't support diesel and some of these other architectures that are very popular. But on the upside, we're able to support the electric in the best way possible as we see it. So this has driven some core innovations in both our propulsion technologies and our charging technologies. And we feel like we've partnered with some of the best suppliers in the industry in order to provide the best solution. Currently, we're on our actually working on our fourth generation, but we have 3 generations of electric vehicle out there. So we've been able to do quick design turns in terms of evolving our product, making things better, making things work as well as possible. And I'm going to get into some more detail as we go through the presentation here on areas that we have really excelled per testing in Altoona. This is the Stura testing that Macy was mentioning as well. So on the next slide here, just highlighting some of the high level aspects to Proterra's Catalyst platform. We feel it in several key areas anyway. We've exhibited extremely high performance, and our composite platform will get into more detail in actually each of these 3 areas in the next couple of slides. Our energy storage system, we don't have the advantage that Macy was talking about in terms of BYD being a battery company from the ground up, which in one respect is a negative, but on the other respect it's a positive in that we can partner with multiple different battery chemistries to provide more solutions. And so we've termed this as a TerraFlex energy system to where we can have our single platform support both styles that Sam was talking about in terms of on-route fast charging and an overnight operate all-day charging solution in the same platform. And even in the same vehicle, the batteries can be swapped out mid-life through the vehicle if needed, just because the customer may want to run a different kind of route with the vehicle than they initially purchased it for. And then we get into making the ownership easier. The elephant in the room with the electric transit market is that the upfront capital is higher, but then the operating cost is lower. The industry is seeing battery prices drop considerably as time goes on. And so this isn't going to continue to be the case in the future, but you can see this trend where it costs a little more upfront for an electric vehicle of comparable attributes to a diesel vehicle maybe. But because it's so much more cost effective to operate, you earn that back. And this presents some unique challenges in the industry, particularly the transit bus industry, in the way that the funding is done and stuff like that. So Proterra has come to the table with some solutions for that in terms of financing and services to help alleviate that. I'm actually not going to get into that detail more as the slide goes on. It's just part of the 10 minutes. Trying to cover as much as I can, or the most pertinent kind of stuff in 10 minutes. So on the Catalyst platform, one of the things that we've done is produced a body that's all composite. It's fiberglass. It's got carbon fiber in areas that we need more strength. This has allowed us to have the lowest rear axle weight in the industry. It allows us, because we have a lower mass in general on the vehicle, we do less damage to the roadways. Because we have less mass on the vehicle, we can carry more load, more passengers, more of the customer that we're ultimately servicing. So being light pays off in a lot of different ways. It also pays off in efficiency. A big aspect to efficiency is the amount of mass that you're propelling around, and so This is another core area that has helped in. Citing numbers from Altoona reports, that's where these greater than 15% more efficient than any other in the industry. That's where that number is coming from, and the 1.7 kilowatt hours per mile is coming from the Altoona testing. So we feel like we have a really strong advantage there. So for the same kilowatt hour that a customer pays for in terms of fuel cost, our vehicle will take them further, and that's a strong suit. The other major advantage of this composite body is durability and safety. This technology is used in very high technology industries, but it's also used in boats and things that are more common. It's not a new technology per se, but it really suits this application very well. And so it lends itself to the weight, it lends itself to strength, it lends itself to corrosion. The industry, as Macy had referenced, is a 12-year industry, and we're expecting these bodies to last much longer than that because we don't have the normal things to worry about fatiguing and wearing. Of course, there might be some refurbishment needed. The axles may rust the same as any axles rust or whatnot, but that can be part of a mid-cycle enhancement. On the TerraFlex energy storage system Proterra has, the real strength to this is kind of what I mentioned earlier. This same platform can support en-route charging solutions. So a solution, to cite an example, we have a customer in Pomona, California. They were our first electric bus customer, Foothill Transit, and they're running around with 15 buses right now. And they're running a fast charge system. So they're running the TerraVolt FC for fast charge. And they run about a 45-minute loop and charge in about 4 minutes, and they run all day long. That route for them is Route 291, and they could run it 24/7 if they needed to. That application is perfectly suited for the fast charge. Other applications would also be suited for fast charge as well, but certain applications, the customer may not have capability for infrastructure to install the en-route fast charge. They may just have a shorter route. They may operate for 8 or 10 hours during the day rather than 16 or 20 hours, and so they can be supported by the XR application, which is the other option. And so this same vehicle can be outfitted with fast charge or XR extended range, and the customer can come back and say, hey, look, I want to change. I've changed my mind. I really kind of like the way fast charge works, the way XR works, and that same investment in those vehicles can be repurposed by swapping out the battery systems. So it's a real strength. The other strength in that is that we can work with the best battery manufacturers in the world because at any given time to provide the best solution in the world. So our LTO batteries here, these fast charge batteries, we're currently working with Toshiba. Previously, we had worked with Alternano. We're not locked into a specific solution, and it allows us more flexibility to, as time goes on, continue to provide the absolute best product, the most innovative product on the market to our end customers. This last slide here gets into the charging technologies, and so with great energy comes great charging needs, or with en-route solutions, you need new and innovative areas. This is an area that Proterra kind of pioneered. The en-route charging at Foothill Transit would be the first application that we used. We charge at about 400 kilowatts peak. It's DC. It's a semi-autonomous docking process. The general customer needs were the customer wanted to come in. They wanted to be able to operate long days. they wanted to do it as low cost as possible, and they wanted, and so that drove us to do on-route charging. And then they also have rules about their operators, and so can the operator get out and plug it in every lap at the depot or whatnot? And so that drove us to an automated connection system. And the automated connection system, for safety reasons, drove us to the overhead. And so Proterra had to do a lot of innovation in this area to come up with solutions in areas that hadn't previously been explored because they hadn't been needed because this hadn't been done before. So there's a lot that goes into that. Wireless charging is something that customers frequently ask about, so that is something that Proterra is exploring as well. And depot charging is what you need for overnight charging. And so Proterra had initially done some proprietary kind of technique for depot charging. We basically repurposed an off-the-shelf charger with our own communication protocol. But now we've moved forward with supporting standard SAE 1772 CCS charging, which is the DC fast charging that most of the auto OEMs in the U.S. and Europe have adopted. It's the counterpart to CHAdeMO. So that kind of concludes my presentation. I appreciate the time from everybody. I appreciate the opportunity.
Excellent. Thank you, Seamus. And this is the point where we will take questions and pass those questions along to the panelists. We've had a number that have come in. As a reminder, if you have a question for the panelists, please type it into the chat box and send it to us. So first, I have a question here that is related to the Sam, your comment about cost parity and the concept there. I wondered if you could expand on that thought. The upfront costs can be different, but the value proposition can still be there. So I'd like to hear more of your thinking there, and others feel free to chime in.
Sure. I would say that the bus market, because the buyers are essentially fleet managers and it's their business to manage the fleet, they're very different from for instance, from automotive buyers. The number one differentiating point and the number one question that people want answered when they buy a car is, what color is it? Of course, people who buy buses don't care about the color. They care about how much is it going to cost, how much is it going to cost to operate. And when you look at the total cost of ownership, the lifetime cost of operating that, so you're factoring in fuel, you're factoring in maintenance, you're factoring in the upfront cost, driver costs, everything. That is where the electric drivetrain has very considerable advantages. And luckily, you're dealing with a buyer that's what they're interested in, is that total cost of ownership. In terms of the upfront cost, I can't imagine a world where electric drivetrains will be cheaper to buy than a diesel engine. It's always going to be a premium for an electric drivetrain bus. So the question isn't when are they going to reach cost parity, because they won't, and it doesn't matter because it's the total cost of ownership that matters. But what does matter is that even if the total cost of ownership is advantageous for electric, that upfront cost still does matter, and that there has to be an acceptable premium of the cost of the electric buses over the traditional internal combustion engine buses. And in my analysis of this market, we're not there yet, which is why subsidies are so important in the early stages of this market. And obviously, the subsidies aren't going to last forever. But what I would say is there definitely is a clear and transparent roadmap towards reaching that level of an acceptable upfront cost premium in the next 5 years, so that around the year 2020 to 2022, the buyers will be looking at a relatively small 10 to 20% premium for an electric drivetrain vehicle over a internal combustion vehicle.
Great, thank you, Sam. Any other comments on that point, or actually I might expand the question just a little bit. the idea that fleet managers think differently than the rest of us when we buy vehicles. I'd love to hear some of the experience of the companies here represented on working with the fleet managers and understanding their concerns and addressing them. I'm sure that first cost is an important issue, but I'm sure also issues like charging and whether it's on-route charging or overnight charging in a bus depot are inherently important parts of the conversation. But you've lived through this and made the sales, and so I think if you could share some thoughts there about what it might take to turn the corner and convince someone who maybe wasn't all excited about electric drive vehicles on why they should be or how they get there. That I'd love to hear some thoughts there.
Yeah, hi, this is John. This is John Archer from BAE. I can kind of share a few transit stories. We've had properties say we want to go all electric, and we're interested, and we see that as the end state. There's the factors that they run into is the ability to have flexibility in their routing, and not knowing how the demographics will shift. So it's one of the things they hesitate when they start considering installing plug-in chargers, which is sort of why I think overnight charging is really going to be will penetrate the market quicker than en route, just because it does give you the flexibility of putting the bus, having it go out for a certain range and come back at night. But also working with public works departments, ripping up roads, et cetera, and tying into the grid and working with utilities is, in some cities, it's more cohesive than others. And it's really a case-by-case basis.
Great. Thanks for that. Any other of our presenters care to comment? We do have other additional questions that I can move into.
Hi, yeah, this is Macy. Can you hear me?
Yes.
Yeah. I think for this to succeed, I agree with the fact that there is always going to be some price delta over just a plain old diesel engine. There's CNG is more than a diesel, hybrid is more than a diesel. I think anything we turn to as a solution or that divorces us from fossil fuels and reduces our carbon footprint and moves us towards sustainability is going to have an inherent cost differentiation just because of the technology, at least in the short term. So I think this industry doesn't become successful until we turn the conversation away from initial capital acquisition costs to total life cycle costs. Start factoring in, where's diesel going to be 5 years from now, 10 years from now, 12 years from now as far as pricing? What are the oil-producing nations going to do? What's the next war? What kind of embargo? All the political and economic arguments that go into how diesel pricing gets set, versus the ability to generate our own local electricity here in our own country without dependence on any outside forms of energy. So I think that when you start talking about life cycle costs, you start looking at a 12-year life of a bus, we can start looking at several $1 million per bus per 12-year life cycle, and that's where the conversation needs to go. Incentives are nice. California has a lot of incentives right now. So does New York. So does Chicago. But I think this industry becomes self-sustaining and stands on its own 2 feet when we divorce ourselves from the dependence on those kind of subsidies and start looking at making the economic case for the vehicle based on life cycle costs. And with that, I'm off my soapbox.
That's great. Thank you. See, we have another question here that relates to is the main drawback for e-buses today the lack of comparable range to fossil fuel buses? How does this compare across different technology platforms that the presenters are showing? So, any comments there?
Yeah, this is Seamus. I guess I'll take that one. I think there are applications where the range is significant and important. The industry is coming from a diesel world where you don't think about range. to an electric bus world where, depending upon the application, it can be an absolutely critical aspect, especially with traffic jams and weather conditions and stuff like that, varying dramatically the amount of energy that you use, and just the fact that the vehicle is so much more efficient. You don't have other things that you take for granted, waste heat energy for heating the cabin and stuff like that. But different applications, so an en-route application, Proterra has demonstrated over 700 miles in a day with an en-route charging solution, and that was using a 250 kilowatt charger, so a half-power charger for us. And we've demonstrated 250 miles on XR. Now, in both of these cases, I would say the XR 250-mile demonstration, we weren't running on city streets. We weren't running an actual route to get that number. And the 700 miles, we weren't running an actual route either. And you look at just average bus speeds in terms of 6 miles an hour or whatever, but it can run continuously, the fast charge, for 24 hours a day. So the range problem often gets brought up and is often a forerunner in the concern list for adopters of electric vehicles, but it's not necessarily a prohibitor in terms of depending upon the solution and depending upon the needs. And we find range anxiety with the transit agencies is just as relevant as it is with a consumer buying an electric vehicle. They may drive 90% of the time less than 40 miles, and so their electric range of 50 miles is more than enough, but they're still concerned about it, and it's still a prohibition to adoption.
Okay, great. Thank you, Seamus. We've had quite a number of questions that relate to charging infrastructure and the differences between a transit agency that chooses overnight charging versus en route, and then a set of questions also around charging standards. And I know that there is ongoing work, but I'd love to hear some of your thoughts on the applicability of different types of charging. How do you make those decisions? And then secondarily, what if a fleet purchases a bus and a charger from one manufacturer, are they now tied to that infrastructure, or are there sufficient standards in place? And I know it's been touched on before, but I'd love to hear a few more thoughts on that. Thanks.
This is Seamus again. I guess I just finished talking, but I can lead again on this one. Charging. This is a real hot topic. It's a common question that comes up, and the industry is working on it. I think Macy was just involved in a phone call that I was involved in with SAE J3105 a couple of hours ago. And so this is the en route charging standards organization definition meeting. And so SAE is working on it. APTA is working on it. We're working on it as an industry topic because we recognize that having a standard en route charging solution is a prohibitor to adoption, and so everybody recognizes it, and I think we're all working to the same goal in that regard. When you choose en route versus overnight charge is really driven by the application. Some transit agencies are running 24-hour operations, and so there is no opportunity for overnight, and so that kind of focuses them on the en route kind of solution. Other transit agencies don't have the ability or desire to, or don't want to narrow down their flexibility by installing infrastructure for en route charging, because obviously if you put in a charger at 4th and North Street, your route has to pass 4th and North Street, and so if in 2 years you decide to restructure that route, you're going to have to go through that point to charge, or you're going to have to move that infrastructure. So there are pros and cons to both. Also, getting into the cost of electricity and the effects on the grid, there are pros and cons to both in that regard too. Overnight charging, the cost of energy and the demand charges and the time of use charges, the actual cost per mile effectively is reduced versus charging during a peak demand period during the day. But that's also changing too as green energy ramps up in terms of the duck curve and phenomena like this, where it's actually advantageous to charge during the day in cases where it didn't used to be. So on the flip side of that, if you have a fleet of, say, 100 buses and you need to charge them all during a 4-hour window at night, you're looking at extremely high demands compared to spreading that charge out over the opposite, the 20-hour operational window. So you're looking at 5 times the demand simply because you've moved your charging operation from a 20-hour span to a 4-hour span. And so that's something else that plays in. It really comes down to, and I see the same thing that was mentioned earlier, the overnight charge solutions are going to be easier for the industry to adopt because it's easier to kind of tip your toes in to the electric vehicle world and not worry about the infrastructure aspect with just buying an overnight solution. But I see the end game as being a combination of both solutions, just because there are places that each of them excel.
That's great, Seamus. I really appreciate the input there. And unfortunately, looking at the clock, we have exhausted our hour, and I apologize that we didn't get to all of the questions that we had submitted, but we did our best to work our way through the group here. I'd like to offer again thanks to the presenters and let everyone know that the slides will be made available at a date in the near future. Do we have any closing comments, Denise?
Sure. Thanks, John. I do want to thank everyone for joining us today. I want to point out that we did notice that a number of you are not members of New York Best, so please take a look at our website, and we encourage you to become a member. It's an incredibly cost-effective membership, those of you who are interested in price, and we work both on electric grid and transportation issues. We have an event coming up in March, our Capture the Energy conference, which is our largest conference of the year, and we will be talking about both electric grid and transportation issues and the role for energy storage and batteries and fuel cells. We encourage you to sign up. There's exhibit opportunities and opportunities to join us as an attendee. And then lastly, we just want you to remind you that there is a survey at the end once we close the webinar. Please just take a minute to fill that out. We do 4 webinars a year on different topics. We're always open to suggestions, and we're interested in your feedback on other topics you're interested in hearing about. Again, we thank you for taking the time to be with us today, and we look forward to seeing you at future events. Thank you very much.